Hi everyone, I wanted to go over one last skill that we need for the normal curve unit. And this skill, I think we got up to in one of my classes, but I'm just going to go over it again with all of you. It has to do with working backwards, given an area to find a score when we have a normal curve. So this is actually, if you can look in your notes, look on day 5, normal areas. And this is about the 3rd page down. It's number 2. Okay, so let's start with this question. It says, SAT verbal is normally distributed, specifically approximately normal, with N. That N means normally distributed. This first number is the mu, the mean, 505. And the second symbol is the standard deviation, 110. So that is just telling me about the distribution, which is approximately normal, with a mean mu centered at, oh, that's bad. I should just erase that. Start over there. A mean mu of 505, a standard deviation of 110. And it says, how high must a student score in order to be in the top 10%? Okay, so in this case, they're not asking me to find the area under the curve or the probability that someone is in the top 10%, because they actually gave you the area. Gave me a percent slash area. So basically, because of that, this is actually going to be a working backwards situation. So they said this person's in the top 10%. So if they're in the top 10%, then they're going to be somewhere to the right of the mean. Okay. And if they're in the top 10%, the area to the right of them is going to be 10% or 0.10, which means that the area to the left of them, which is who they're better than, is actually 90%, which is the complement of 10%. Remember, these have to add up to 100%. So 90 plus 10 equals 100%. So basically, this person is in the 90th percentile because they are better than 90% population. So the first thing that we always want to do is draw and label the curve and sketch and shade the area that is given. Okay, the second thing you always want to do is you want to find the area to the left of the score, not to the right of the score. So they gave me the area to the right, but I always want to use the area to the left in this class. So step 2 is find the area to the left of the score. All right. So to do that, I just did 1 minus the area to the right of the score. Because remember, they're complementary. They add up to 100, 1 whole. All right, so now let's say I wanted to use my table A, right? If you use table A, you know that we were looking up the z-score in the outer margins and then lining it up to the middle to find the area in the middle. Well, using this technique, we're actually going to be working backwards with table A. So you're going to work backwards using table A, using specifically the middle of the table to find the closest area to whatever the area to the left is. Okay, I'm going to explain right now. I'm going to pull up the. Okay, so here's my table A. There's positive z-scores and negative z-scores. This is the negative z-scores, and these are the positive z-scores. We are on the positive z-scores because remember, we are to the right of the mean if we're in the 90th percentile. Okay, so what we want to do is we want to look for the closest area in the middle of this table here, right in the middle. When I'm saying in the middle, I mean like this part in the middle here. Look for the closest area to 0.90. So this is where you have to kind of use your eyes, and it's not easy to find the closest to 0.90. They do go in order from the top left, 0.5, all the way up. So try to find the closest area to 0.90. It's actually going to be this one, 0.8997, okay? That's off by 0.0003. So then what you want to do is you want to take your fingers or your eyes and you want to look outward from that score. You want to look outward to find the z-score corresponding to that area. So the area I'm going to circle again here, 0.8997, and then I just look to the table to the outside margins and I see that that corresponds to the z-score of 1.28. So that's what we wanted. We wanted the z-score. So now that I have my z-score, the last thing I need to do is I need to find the actual score on the SAT because 1.28 is the standardized score, but it's not actually the score that the person got on the SAT. So what you have to do is you write your z-score formula in symbols. We always recommend it. And then you're going to plug in the z-score that you got, 1.28, in for z. You're going to leave x blank because we're going to solve for x. And you're going to plug in your 505, which is your mean, and 110 was your standard deviation. And then you're going to cross multiply and solve. Okay, so step 4, plug in the z-score, the mu, and the sigma into the z-scores formula and solve for x. I'm going back to step 3. It looks like I didn't finish my thought. It said work backwards using the middle of table A to find the closest area to the left and find the z-score corresponding to that area. Okay, so now I'm just going to put a 1 under this. I'm going to cross multiply. I'm going to do 1.28 times 110. Whatever I get, I'm going to add the 505 to that, and I'll get my answer. So do that now, if you didn't do it already. Okay, so I got 645.8. So 645.8 is going to lie right here with this z-score. But remember, you can't have a decimal on the SAT. So if you want to know how to land in this right area, which is the top 10%, I'm going to round this up. And I'm going to round it up in this case because I want to land in the top 10%. Now, if I was working the other way to the left, I would have actually rounded down to land in the bottom 10%, but it depends on the situation. So if a student gets a 646 or more on the SAT, they will be in the top 10% with respect to their age group. Now, it turns out the calculator method is actually much easier for this. So I'm going to show you that next. And I will just first, I'm going to write some of the steps here for you, and then we'll show you. So on the calculator, you're going to press second bars. And then instead of going to number 2, which is normal CDF, you're going to go to number 3, which is inverse norm. And I want you to think about inverse means backwards or opposite. So we want to choose opposite. And then it's going to ask you for the area. And you can put in the area to the left of the score there. And then choose left if they have a choice there for left, middle, or center. And then you're going to put in your mean and standard deviation. You're going to hit enter. And it's going to give you the answer. So unfortunately, my calculator app is not working right now, but you would press second bars, press 3, put in the area to the left, which is 0.90, put in the mean, which was given to us in the question was 505, put in the standard deviation 110, and when you hit enter, you're going to get the same answer for the score, okay? Approximately 645.8, all right? All right, let's move on. Let's do a few more examples. So if you look at this next one, it's talking about the ACT and the SAT. The first one's asking about Jose and what he got on the SAT versus the ACT. So I just want to remind you, when you're organizing yourself, you're going to just put SAT and ACT, and then you're going to be organized about what he got. So I got 0.85. And then the next thing I'm going to do now is I'm going to go to my z-score. I'm going to plug in for Z what I got for his SAT score and solve for X to get the equivalent ACT score. So do that now. So my answer I got for Jose's score on the ACT was 24.98 when I cross multiplied and solved. So now it says we can also be given a percentile. So here's where we get into percentile a little bit, and that's more about the area under the curve. We want to know what Tanya's percentile was on the SAT. So Tanya scored a 1320 on the SAT. The SAT mean above is 1499 and the standard deviation is 319. First thing I always do is recommend that you draw the sketch and label and shade what you know. So where is Tanya with respect to the mean? The mean was 1499. Sorry. The mean was 1499. But Tanya was to the left of the mean. Okay? So if you know that Tanya's to the left of the mean, you can just put a random line to the left of the mean and label it X. Her percentile is the percent or area of scores less than or equal to her. So that's going to be the area to the left of her and including her, okay? So we want this, okay? So if we're doing this by hand, we're going to find the z-score for Tanya, and then we're going to use table A to look it up. So find the z-score for Tanya, get your z-score, and then go to table A and look up the 2-digit z-score and see what you get. All right, so I got a z-score of negative 0.56. And now if I want the area to the left of her, I just go to the table, I look up negative 0.56. Remember, it's negative 0.5 on the left and 0.06 on the top, and where they line up should be 0.2877. So this is her percentile. That means that Tanya is in the 28.77th percentile. And what does that mean? It means that she is better than 28-ish% of the population, which actually means that a lot of the population is better than her. So keep that in mind. All right, so this is the last part that I wanted to get to with you. And this says the quartiles of the distribution are the cumulative proportions of the 0.25 and 0.75, aka the 25th percentile and the 75th percentile. What are the quartiles of the ACT score? So let's start with the 25th percentile, okay? 25th percentile is going to be your Q1. Draw the bell curve. In the middle, put the mean for the ACT, which was 20.9, okay? Now, if you want the 25th percentile, aka quartile 1, you're going to be somewhere to the left of the mean. You're going to call this Q1, and you're going to show that the area to the left is 0.25, okay? Now, if you want to find the actual X value for the score, you know it's going to be less than 20.9, okay? Now we're going to go over to table A. Specifically, we're going to go to the negative z-score side, and you want to look for the closest 4-digit area to 0.25. So remember, it goes in order. Just start looking and seeing if you can find the closest 4-digit area to 0.25. It's going to be around here-ish, right? Maybe this, maybe this, maybe this. So it doesn't seem that close, but let's say it's this. Then you're going to go out with your pen or your eyes, and you're just going to see what does that correspond to. So it looks like negative 0.67 for Z, and you know it's going to be negative because it's to the left. So this is Z, negative 0.67. So now to solve for X, you're going to have the Z-score formula. You're going to plug in the z-score that you know. You don't know X. You're going to plug in the mean, 20.9 for ACT, and you're going to plug in the standard deviation, which is 4.8. And then you're going to cross multiply this and solve for X. And that's going to give you the value of the first quartile. Okay, do that now. So the answer I got was about 17.684. So that would be the first quartile. So now if you wanted to do this third quartile, Q3, you're going to do the same thing. except it's going to be on the right of the mean, so it's going to be a positive z-score. And your area that you're going to get is going to be to the left, so it's going to be this whole area. So you want to look for the closest 4-digit area to 0.75. You try it. Thanks for listening.